Calc 2 problem. We're going to find the series representation for a function ln of the quantity 1 minus 3x divided by 1 plus 4x at x equals 0. So that's where it's centered. State the values of x for which this series is valid. Okay, so when you're working with these types of problems, first thing you have to work with is a series representation of a Maclaurin series or any other like Taylor series where you're centered at. In this case, yeah, we're going to be working with a Maclaurin series to start off with because we're going to be centered at x equals 0. And here I'm going to work with ln, a series for, in particular, ln of 1 minus x. That's a Maclaurin series that's centered at 0, and it's equal to minus 1, or just minus sigma from 0 to infinity, xn plus 1 over n plus 1, or if you prefer to write it out term by term, it's minus x squared over 2 minus x cubed over 3 plus da 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 minus x to the n plus 1 over n plus 1 dot dot dot. Now, this series is valid for particular values. It's valid from negative 1 inclusive to 1 not inclusive. Okay. Now, if you want to, you can rewrite this series out as well with a sigma notation starting at 1 here, and it would be xn over n. That's how you would find your general term. The interval of validity, or the interval of convergence, is the same, goes inclusive at minus 1, not inclusive of 1, and includes every number in between. And the radius of convergence, if you're interested for both of these, is equal to 1. Okay. So we're going to use that. Now, before we do, though, you will often have to simplify the function you're working with so you can use that information. Right now, it's really hard to use that representation, or those representations that I just wrote, and use them here as of the moment. And here's what I'm going to do. I'm going to use algebra, and if you recall your rules of logarithms, the log of a quotient is equal to the log of the difference. So it's ln of 1 minus 3x divided by ln of 1 plus 4x. That's another way of writing that. And I did that again as well, just so I can use my information about my series. So if I know that ln of 1 minus x, and here's how we'll use that, is equal to negative n equals 1 x to the n over n, then ln of 1 minus 3x is equal to 3x all raised to the nth power over n. And yes, we're allowed to substitute that in there. This substitution preserves your center. And basically, as long as your substitution preserves your center, you can plug that in and you have a valid representation of the series. So the series representation for ln of 1 minus 3x would be minus 1 to infinity, 3 to the n, x to the n over n. And I use properties of exponents here to simplify that, just to let you know. Now, the thing that does change, though, is or could change, is in this case it will, the interval of convergence. So originally, this was valid from minus 1 to 1. Our series, similarly, will have a interval of convergence that does include the left-hand point as part of it, and not inclusive of the right-hand point. So it's inclusive of minus 1/3 and 1/3. And essentially what you do is, what you substitute, you can put it in between these, the original inequality for x, and then you just solve, okay? So that's your interval of convergence. And we're going to do the same thing for ln of 1 plus 4x, okay? Now with ln of 1 plus 4x, I'm going to use the series ln of 1 minus x, but I'm going to note that ln of 1 plus 4x is like saying ln of 1 minus negative 4x, and that's so I can match my series here. And that would equal minus sigma from 1 to infinity of minus 4x to the nth power all over n which becomes n equals 1, negative 4 to the n times x to the n over n, and that negative 4 to the n would become negative 1 to the n, 4 to the n over x to the n over n here. And finally, this will become sigma 1. That minus, that's a minus 1 really. I'm going to bring it up like in there, and that's going to become minus 1 to the n plus 1 using rules of exponents. Okay. And your series representation here will be valid for the values between minus 1/4 inclusive and 1. Okay. So, okay, great. We found our two representations for our series. So what about our final answer? Well, you might be thinking, am I just going to go ahead and put both together? And essentially, yeah, that's how this is going to work out. So we're going to have ln of 1 minus 3x, so the series representation for that was 3 to the n, x to the n over n with that minus. And then for the series from 1 to infinity, oh, sorry, let me just put that in here. The one for ln of 1 plus 4x, I'm sorry, minus 1 to the n plus 1, 4n x to the n over n. And well, let's do this. I'm gonna take the negative that you see here, and I'm gonna bring that in. And this is gonna be negative 1 to the n plus 2, 4 to the n, x to the n over n. Okay, so again, the negative that I had here originally, the minus in between the ln of 1 minus 3x and the ln of 1 plus 4x, I brought it inside here, and when you bring that in, oops, I did not write that down. This makes that an n plus 2, excuse me. Okay, so yeah, that minus again changes this to a plus 2 because you have one more minus 1 in here. And that would be your series representation pretty much. Some people say, can you factor out the sigma here? Yes, you can. But we have to actually say something that's really important here, which is for what values of x is your series valid? Okay, this expression holds, truth to it only if you state for which the interval of convergence, the radius of convergence, whichever you prefer. That's the same. That's the case for all series. Okay, and how do I know what that will be? Well, your first series went from minus 1/3 inclusive to 1/3 exclusive. And your other series went from minus 1/4 to 1/4. So your series basically that you're looking for satisfies both of these at the same time. So that's the interval from negative 1/4 to 1/4. Okay. So always keep that in mind. The interval that works for both is what you're looking for. And that would be it. There's a couple other things you could do to simplify this. You could take out an x to the n out of that and then put this all over n and whatnot. That would work out. And, oh, might as well just do it here. This would be minus 3 to the n over n plus negative 1 to the n plus 2, 4 to the n all over n. And last but not least, you can write this as minus 3 to the n plus minus 1 to the n plus 2, 4 to the n over n, x to the n. Okay, n equals 1. And again, we can certainly do that because we have a known radius of convergence, an interval of convergence, excuse me. Okay, so I appreciate your time. Thank you very much. I hope this helps.